streaming now.
Hello students, I'm Mr. Abhijit Kundu. I'll be talking today on laws of motion. So, we are already studying the questions for NEET, for your NEET preparation. So, you are already on your roll, right? So, today, in the third day of physics, we'll be starting with laws of motion. Now, laws of motion is a part of physics which is called mechanics. Mechanics is one of the mother subject of physics, one of the mother part of physics, and if you can master mechanics, I can tell you the basic groundwork for physics is done, and you can move on to further topics such as wave motion, such as even electrostatics, right? Even you can move on for like us in semiconductor physics also. But the mother subject of physics is the mechanics portion. So already in the previous classes you have completed units and measurements, isn't it? Units and measurements, and also I think you have done kinematics. Now see, what does this word mean, kinematics? Kinematics is nothing. It is dealing with bodies which are in motion. Now today also we will study bodies in motion, but plus we will study the causes which produces this motion. So kinematics is just study of the body in motion, study of the particles in motion. But if we now add the causes, then we get something called dynamics. And the laws of motion actually deals with dynamics. And what is that cause? You all know, I don't have to say, it is nothing but force. Force and related things. So, study of laws of motion basically mainly deals with force, right? And in nutshell, we can say we will be studying today dynamics. Okay, let's move on. The basic, see, we'll not be going into the topics in detail because that you know from your board classes. We are mostly preparing for NEET exam. So in a nutshell, I'll tell you what are the topics that we deal in laws of motion. Like you need to know about the types of forces, contact forces, non-contact forces. You must have studied about free body diagram, which is a very, it's not exactly any topic, but a technique by which we can, which the problems of forces becomes very easy by using free body diagram. Then you have equilibrium of forces. We have the 3 Newton's laws of motion and how we apply them. Impulse, I'll talk about it, right? Impulse is to do with momentum into time, right? Conservation of linear momentum, that will do. Okay, this is a very interesting and this is a little bit confusing portion. We'll be dealing these 2 things. Non-inertial frame of reference will see with specific problems, and pseudo force. Pseudo force is nothing but when actually there is no force, but because of non-inertial frame of reference, the body experiences a force, right? It comes with the equation. We'll solve few problems and you will understand. Friction is one important point, and circular motion. So basically these are the topics that we will cover in different problems. And before starting the problems, I'll tell you, like in NEET and in this kind of competitive examination, what happens, you keep in mind calculation is very less. Calculation is very less. The main target of the problem is to question you, or is to see how far you have grasped the concepts, the various concepts. So in these problems you will see the calculation is very less. So you don't have to bother about calculation. Just have to know the concept and how you can utilize very simple formula. All the formulas that we have in physics. One thing to remind you, this chapter especially, that is laws of motion, has very less formula. Mostly the formula are with what? Are the mainly it is F equals to ma, force equals to mass into acceleration. The definition of momentum equals to m into v, and also we use mostly all the formula for of kinematics. Kinematics जितना भी formula हम लोग सीखे हैं, we utilize all those formula into this. Okay, let's start with our problems. Okay, I'll start with the first problem. A man of mass 60 kg is riding in a lift. The weight of the man when the lift is accelerating upwards and downwards at 2 meters per second square are respectively. So we have to find out what are the weights of the man when the lift is accelerating upwards and downwards with an acceleration of 2 meters per second square. We have to take g equal to 10 meters per second square. Now this is a classic problem of where when you are or a man is within an elevator. Now what happens when somebody is in an elevator? Right? When the elevator is stationary, definitely you will feel that is the weight of the man is nothing but your normal weight, that is mg. But when the elevator moves up or moves down with an acceleration, then there is a change of weight that the person experiences. Why this happens? I was telling you about pseudo forces, right? See, the first problem we are starting with this, the toughest part, one of the toughest part, but it will be helpful because if you understand this concept, many things becomes clear. Pseudo force and non-inertial frame. Let me explain both these, right? See, inertial frame, non-inertial frame. When a person is standing at a platform, suppose this platform is at rest. This platform is at rest or in uniform velocity. Then we say this frame of reference, that is the frame of reference for the person, if we take the platform to be our frame of reference, is inertial. But if the platform itself is moving with an acceleration, right, then what happens? Then we say this frame is non-inertial. When the frame itself is non-inertial, then what happens? All the bodies which are on the frame, they experiences a backward acceleration with which the body experiences a backward acceleration with which the frame is moving. Right? So body experiences a backward acceleration. The force will be what? If the body's mass is m, it is nothing but ma. Right? With this concept, if we try to see the lift problem, what will happen? We have drawn like this, right? So if first case, if the lift is going in the upward direction, that is here acceleration a, the lift is moving in the upward direction. So the lift is nothing but the frame, and the body, that is the man within the lift, will experience a pseudo force. Yes, I didn't name this force. This force with which the bodies in a non-inertial frame experience are known as pseudo force. Why they are called pseudo force? Because actually there is no force. Because of the non-inertial nature of the frame, the bodies are, they're experiencing a force in the backward direction, right? And that comes because of inertia. If we talk about first law of inertia, you will understand. Okay, let us come back to the problem. So what happens when the lift is going in the upward direction, the man, he will experience a force in the downward direction, which is equal to mass into the acceleration, right? And also in the downward direction, he is also having the weight mg. The total force will be what? M a plus g, right? And in the case when the lift is going in the downward direction with an acceleration a, then the man will experience a force of a in the upward direction and the gravity g is in the downward direction. So the net force will be mg minus a. See, here I have taken ma plus g, means g plus a. Here I have taken g minus a. Why? Because mostly the acceleration of the lift is much less than the gravity. As we can see in the previous problem, right? Here the acceleration downwards and upwards is 2 meters per second squared, and g equal to 10 meters per second squared. So coming back to our solution, what we can have here, the weight will be, what is the weight? The mass is 60 kg. The mass is 60 kg. So if mass is 60 kg, so 60 into 10 plus 2, that is 12 into 60, it is how much? It is 720 Newton, and this will be 60 into 10 minus 2, that is 8 into 60, which is nothing but 480 Newton. Right? Okay, let us check the answer. See, 720 upwards, 720 and 480. Students, you need to be very careful while answering. See, 720 Newton and 480 Newton is marked here also. At the same time, it is marked here. But to follow the question, when the lift is accelerating upwards and downwards, so first they want to know what is the weight when it's going upward, that is 720, and downward is 480. So definitely this will be our answer. Right? Understood? We are moving on to the second problem. Okay, the second problem says, okay, the x and y coordinates of a particle at any time t are given by x equals to 7t plus 4t squared. I'm writing it once more. X equals to 7t plus 4t squared, and y equals to here written 5y. There it is some misprint. It should be t, 5t. That is y equals to 5t. Right? So x and y coordinates of a particle at any time t are time dependent. These are the equations where x and t are meter and t is in second. We have to find out the acceleration of the particle at t equal to 5 seconds. Now see, x and y, what are they? X and y are nothing but the position coordinates of the particle. The particle, where the particle lies, it is nothing but the position. Now from the position, how can we get the acceleration? So these are time dependent position, means they are nothing but the displacement, right? How the particles are moving, that is the equation. These are the guiding equations. Now if we differentiate x and y with respect to t, we'll get the velocity, and we'll differentiate again, we'll get the acceleration, right? Let us try to do that. So if we do dx dt, means this is nothing but velocity of the particle in the x direction is nothing but 7 plus 8t, clear? And if we do dy dt, that is v in y direction, is nothing but 5. This constant, very interesting. The y, that is the velocity of the particle in the y direction, is a constant, but in x direction it is having still a time variable attached to it. So for acceleration, definitely ax will be dt of, that is differentiating it once again, so it will be nothing but this is 0, it is 8, so acceleration I have to write 8 meter per second square, and acceleration of this ay is what? Differentiation of a constant is 0. So acceleration of the particle at t equal to 5 seconds. Very interesting. If you just find the acceleration, you will see acceleration is just constant, and that is only along the y, only along the x-axis. Right? In acceleration, in ax it is a constant term 8 and ay is 0. It means, so acceleration is not time varying. There is no time variable attached to either, not in ax, not in ay. So we can directly say the acceleration of the particle at whatever be the time. Here the question is time equal to 5 seconds. If it could be 105 seconds also, right, acceleration will be only this. Acceleration will be only this, and that also in the x direction. These are not marked in the problem, said in the problem, but suppose this kind of question, this kind of addition in the question also be there, you can be able to answer. So this should be the approach, how you solve the problems. So this is our answer. Understand? Okay. So we are moving on to the next question. Okay. The next question. A ball of mass 0.5 kg is moving with a velocity v of 2 meters per second. So mass is given m and velocity is given 2 meters per second. It is subjected to a force of x Newton. So x is unknown. This we have to find out in 2 seconds. So time is given t. Because of this force, the ball moves with a velocity of 3 meters per second. What is the value of x? Now see, this is a very simple question. It can be solved in 2 ways. One, first is just what you know about force. Force is nothing but mass into acceleration. What is acceleration? It is nothing but rate of change of velocity, that is v minus u by t. V is the final velocity, u is the initial velocity, right? Force we have to find out, right? So force, here it is, I should not write it F because they have given, okay, fine. I can just make it X. What happened? It is nothing but X. This force we are finding out, X, right? So F equals to m into a, m v minus u by t. V is the final velocity, u is the initial velocity, t is the time. See, everything is given. Final velocity is 3, initial velocity is 2, time is 2 seconds, and mass is given 0.5 kg. I think I haven't made any mistake in the units. No. So 0.5, this is 1 by 2 is 1 by 2, 0.5 by 0.2, it's nothing but 0.25 Newton. Very simple, right? Approach is very simple, but remember another approach, that is the impulse approach. This approach, maybe for this it is not so much required, but you can use it for other problems. What is impulse? Impulse is nothing but change of momentum. It is change of momentum. Change of momentum. Change of momentum is nothing but final momentum minus initial momentum, right? And so impulse is change of momentum. Impulse has another definition, which is nothing but force multiplied by the time for which the force is acting on the body. That is F into T. You will see it is nothing but the modification of the same equation, but we need to understand so that we can understand the physical parameters also. Like F into T is the impulse. Because of F into T, because of force and the time of action of force on the body's velocity is changing and the momentum is changing. So F into T equal to mv minus mu. So if you can find it mv minus mu in this, then divide by T, you will again get the value of force. They are basically the same, but try to understand the difference, how we are, how the physical parameters are changed if we just interchange few of the, variables of the formula. Understand? Okay. Moving on to the fourth problem. Yeah. See, fourth problem, again we are coming back to the first topic that we are discussing on pseudo force and non-inertial frame. In non-inertial frame, the second law of motion is written as. So what I said, in a non-inertial frame, if this frame is inertial, means this frame is either at rest or with uniform velocity, right? Then whatever force will be given in this body, right, that will be, force will be equal to mass into acceleration, simple. But if this frame now starts moving, right, with an acceleration, it becomes a non-inertial frame. When it becomes a non-inertial frame, then this body will experience a opposite force, right, which will be equal to, the opposite force will be equal to the mass of the body into the just have to erase this. If this moves with an acceleration a, then this will become what? Okay, fine. If this moves with an acceleration a, then this body will have a force acting in the opposite direction, which is equal to mass of the body into the acceleration of the frame. Let me say this acceleration AF, so that I can differentiate from the acceleration, actual acceleration of the body within the frame, right? So MA into F. Now this is nothing but, we can name it as a pseudo force FP. Now what happens? F minus FP equals to MA, or I can say, yes, I can say F, the net force acting, F equals to MA, yes, F equals F minus, yes, I can say F, the actual force F minus FP. Now it will generate the net force is what? The force, suppose you have given a force F, right? And also there is a pseudo force in the opposite direction, FP. So net force will be F minus FP. That will be nothing but mass into acceleration of the body. So I can write F equals to MA plus FP. F equal to MA plus FP. This equation. Understand? This part is quite, you have to practice a lot. You have to practice a lot. There are plenty of problems for NEET, and if you follow some really good books like A.C. Verma, you will get plenty of good problems on this pseudo force, right? We are moving on to the next problem. Okay. This is interesting. This is not a problem, but more of a reasoning. A ball hits a vertical wall horizontally. Means what? There is a horizontal wall. There is a vertical wall, sorry. And a ball is hitting the wall with a velocity of 10 meter per second and bounces back at 10 meter per second. The velocity with which it bounces is also 10 meter per second. Then what will happen? Before going into this, just you think with the problem. Now the velocity for this is 10 meter per second in, suppose, direction x, right? So if this is u is having this direction. It is bouncing back with the same velocity in the opposite direction. So definitely the v, if u equal to 10 meter per second, v is nothing but, v can't be 10, v will be minus 10 meter per second because it's in the opposite direction. Now let us try to analyze. There is no acceleration. Will it be? No, because there is a change of velocity. Change of velocity means there should be acceleration. So it should not be. There may be an acceleration because its initial velocity is horizontal. Very random assumption. There is an acceleration because there is a momentum change. There is an acceleration because there is a momentum change. Yes, there is a momentum change and definitely there is an acceleration. So this can be a probable answer. Even though there is no change in momentum, there is a change in direction. Now see, this is, a very twisted answer. They are saying there is a change in direction, but if change in direction occurs, because of change in direction, there should be a change in momentum. Because of change in direction it is yes, but as they are saying there is no change in momentum, this is wrong. So this portion there lies a fallacy. If velocity changes, momentum should change. Now when momentum changes, then only there is a, if momentum changing within a particular period of time, within a certain time, then therefore force is nothing but, right, rate of change of momentum. Momentum changing within a time, hence a force is generated, and hence definitely if force, there will be acceleration. So only C is right. Only C is right. Others are false. These two are completely wrong. But people get confused between this C and D because they think even though there is no change in momentum, there is a change in direction. Hence, it has acceleration. See, where a student, they fails to clearly understand. The answer, hence it has acceleration, is right. Right. Change in direction is also right, but the actual reasoning is not right. So what we have to keep in mind, not just the answer, but the reason. This is the answer. And these are the reasons. Both need to be right. Where it is right, there is an acceleration, yes. Because there is a momentum change, yes. Because, why momentum change? Because velocity is actually changing. When the direction change, it means velocity is changing, it means momentum is changing. Clear? Moving on to the next question. Okay. Now there is a question of graph. Okay, one thing I don't know whether you have followed, when I haven't told you very specifically, all these questions are taken from NEET, NEET, the exam that you are preparing for, right? Past papers. So all the previous questions, like I'll just show you. This was in 2009. This was in 2011. Right? If you go on searching for the papers, you will see all these questions. Right? So most of this, all these questions rather, I have taken from the previous year. Okay. Coming back, yes. So this question is from 2008. This is a question on graph. Very interesting question. A body of mass 2 kg has an initial velocity. I need a water. A little bit of water I need. A body of mass 2 kg has an initial velocity of 3 meter per second along OE, and it is subjected to a force of 4 Newton in a direction perpendicular to OE. Very interesting. The body is moving along OE. This is the direction of its motion. The body is moving along OE. So this is direction of its motion. And see, it is moving with a particular velocity. But the force is acted 4 Newton in a direction perpendicular to OE. Right? The force applied is 4 Newton perpendicular. Here the velocity v equals to 3 meter per second. Right? Question is, the distance of the body from O after 4 seconds will be. Very interesting problem. Why? The body is having 2 directions of motion. One along the x-axis, right, which is uniform because x-axis, the initial velocity is 3 meter per second, and there is no force along the x-axis. The force is along the y-axis. When force is along the y-axis, there is no component of force along the x-axis. So x-axis, there is no agency to change the velocity, right? So the x-axis, the velocity is remaining constant. That is 3 meter per second. So along the x direction, what will be the displacement? I can just write along the x direction after 4 seconds, it is nothing but 3 into 4, that is 12 meters. Now we have to see what is the displacement along the y direction. Along the y direction, force is 4 Newton. What is the mass of the body? Mass of the body is given 2 kg. So what is the acceleration in the y direction? Acceleration is nothing but 4 by 2 is 2 meter per second square, right? And when the body, and what was the initial velocity in the y direction? Can you guess? The initial velocity in the y direction is 0 because the initial velocity is given only in the x-axis. So initial velocity in the y direction is 0. So if we say y is nothing but the position. If you use the second equation of motion, which is s equal to ut plus half at square. Here s is nothing but y, u is here 0. It is half at square is nothing but half, here a is nothing but 2, t is nothing but 4 seconds. So it is nothing but 4 square. It comes to 16 meters. So after 4 seconds, this displacement will be 12 meter and this displacement will be 16 meter individually. So what is the final displacement from O? It is this. Definitely. Like this is nothing but a right angle triangle. From Pythagoras theorem, you will easily calculate this distance will be 20 meter. So we have the answer. We have the right answer, right? It is marked with green. It is 20 meter. I'm explaining it once again. So what we did, velocity, don't get confused. Velocity, it mean given mean, it doesn't mean that velocity should be taken in the y direction also. No. V equal to 3 meter per second means it is only in the x direction. And when the force is in the y direction, force is definitely changing the velocity, but in the y direction only, right? So this, it is a uniform motion. For this, it is accelerated motion, and we can calculate the displacement individually in the x and the y direction, and then we are applying simple Pythagoras theorem. Okay, let's take a water break. Very interesting. We have come to another topic. We are dealing with, see, we have done with pseudo force, non-inertial frame, Newton's laws of motion. We have come to topic of friction. Okay. A block of mass 4 kg, this is nothing but mass, is placed on a rough horizontal plane. A time-dependent horizontal force, the force is time-dependent, it is kT, acts on the block. K is a constant, the value is given, K equal to 2 Newton per second. The frictional force between the block and the plane at time t equal to 2 seconds, we have to find out. And mu is also given. Like, what is mu? That is nothing but coefficient of friction. Okay. Before jumping into problem, first understand what is, how frictional force works, right? A frictional force, right, is a self-adjustable force. Means frictional force works only when there is a tendency of the body to move. There is a force, there is an external force on the body which is trying the body to move. It's not that the body should move. The tendency of the body to move itself generates a friction in the opposite direction. So this force is trying to move the body. Hence, what happens? A self-adjustable force, right, generates across the surface. Now, when I say friction is self-adjustable, it means what? That is, till a certain limit, till the body is not moving, right? I'll tell you, whatever force you're applying, right, the friction adjusts itself to that force so that the net force becomes 0 and the body will not move. But there is a maximum limit of that. That is called the maximum, the maximum static friction. That depends on the mu. That depends on mu. And before that, before reaching that frictional force, the frictional force will be equal to the force that you have applied. Clear? Now see, first, before jumping into this kind of problem, first let us try to find out what is the maximum frictional force. Maximum friction that can be generated on this surface where the mu is 0.2. Now maximum frictional force, that is Fs, that is static friction, is nothing but mu into m into g. That is mu times the weight of the body. What is that? So for this, what will be? It is 0.2, mass is 4, and let's g equal to 10. It is nothing but 8 Newton. So if the external force is somewhere less than 8 Newton, right, the frictional force will be just that force, not 8 Newton. So if you apply a force of 2 Newton, right, the frictional force will be 2 Newton only. If you apply the force of 4 Newton, the frictional force will be 4 Newton. If you apply the force of 8 Newton, the frictional force will adjust itself to 8 Newton. But if you apply a force of 9 Newton now, which is more, even 8.1 Newton now, right, the frictional force cannot go more than that. Cannot go more than this, right? So this is the maximum limit of the frictional force. And then what happens? Then the body, the net force will be nothing but, suppose we take 9 Newton, 9 minus of 8, that is 1 Newton will be the net force acting on the body, divided by mass, and we'll get the acceleration. But what would be the friction here? The maximum limit of friction is 8 Newton. So at 2 seconds, now you have given a force which is time dependent, F equal to kT. K here is 2 Newton per second and T is 2. So definitely at 2 seconds, the force will be nothing but 2 into 2, that is 4 Newton. So when the force is 4 Newton, which is less than this maximum limit, right, the friction friction should be 4 Newton only. It cannot go beyond that. Right? Answer will be 4 Newton. So right answer is, say marked with light green. This is our right answer. And very interesting, few problems are given like this. Like, suppose if they say the body is just stationary, it is at rest. What is the frictional force? If the body is at rest, don't write the frictional force to be the maximum static friction. If weight of the body is given, everything is given, mu is given. The body is at rest and no external agency, external force is given, right? The force of friction will be 0 only. Because we are not applying any force, it means there is no friction. Okay. Let's move on to at least 1 or 2 problems more. Okay. This question is of 2006. If a street light of mass m, so this is a street light of mass m, is suspended from the end of a uniform rod of length L in different possible pattern as shown in figure. Right. See, very interesting. See, try to observe this. There is a string, there is a bar, and the street light is hanging. Here, this string is attached to the topmost corner of the bar. Here it is at the 3/4. Here it is at the cable is at half. Right. Now the question is, which pattern is more sturdy? Means more strong. Now, what do you mean by this? Which pattern? I mean, which way of attaching this street bulb is more strong? What do we mean by this? It means definitely it should be stable. See, what are the forces acting in this? In this systems. Let us take this one. Right. See, one is the force, that is the weight of the body, mg. Right. Clear? And also the cable, the tension within the cable, that is T. Clear? Now the weight of the body is trying to rotate the whole thing in the clockwise direction, whereas the cable is pulling it and trying to rotate it in the anti-clockwise direction. So what we try to see, when it is trying to rotate it in opposite direction, they must remain balanced. What need to be remain balanced? The moment of the force. The moment. Here there is another topic, right, called the moment of the force. Now, how to calculate the moment? Moment is nothing but the force multiplied by the perpendicular distance of the force from the axis of rotation. See, for all these cases, this force or this force is trying to rotate the body from this corner. So this is my axis of rotation. So if this is mg, this force mg, for calculation of moment, force into the line of action of force and the perpendicular distance from the axis of rotation. So we have to take this thing, right? So mg, say this is x, say this is x, mg into x will be equals to the tension, this tension, right? This tension, the tension is acting like this, tension into this is y, this is y, this is y, the tension into y. Now see, for all these cases, this mg into x, this perpendicular distance is remaining the same. So this portion, the torque, the moment with which the street lamp trying to bend this structure is same. What is changing? The y, because for this is the y, for this it is 3/4. So by similarity of triangle you can say this is 3/4 y, this is also half y. So in all these cases, from A to B to C, the y is reducing. This portion is reducing. Now, in which system, the system will be more stable, in which the tension with which it will be minimum, right? If tension is minimum, then it means we can increase the tension. We still have some limit to increase the tension. Now see, when y is maximum, then tension is minimum. Because for this, to generate the same thing, we have to multiply it with tension into 3/4 y. So here T dash will be more. Suppose this is T dash into, this is nothing but 3/4 y. That is will be equal to mgx. So here tension is more. For here tension is still more. So tension is minimum in this. So this is the most stable structure. Got it? Okay, I'll do one more problem. I think we have to end our class. Okay, now there is another topic, which is the circular motion, and that is also on a vertical plane. A fighter aircraft is looping in a vertical plane. The minimum velocity at the highest point is given r equal to radius of the loop. Now whenever a body moves within a circle, say the velocity is v, there is a centripetal force, right? The centripetal force is nothing but mv squared by r. Now at the topmost position, at the highest point, right? At the highest point, right? What is the minimum? I mean, the minimum force. It can have its own force, but it can have its own like the aeroplane can has its own driving force. But if we don't consider the driving force, the minimum force it can have in the downward direction is nothing but mg, isn't it? The weight of the body, the weight of the aeroplane will actually give the centripetal force if it needs to move in a minimum velocity. The aeroplane can have mechanism to increase its force and increase the velocity. But here the question is looping, the minimum velocity should be mv, like v, right? So mv squared by r, if we equate with mg, so mass cancels out, v becomes, v squared becomes root gr, it is, this velocity becomes gr, so root over gr. So this is our correct answer. A fighter airplane, yes, root gr. Understand? There were a few more questions, right? But they are similar in nature. I hope you will be able to solve. Go on solving as many NEET problems on these topics. One thing I can tell you, like what you have observed, the concepts are more important than the actual calculation. The actual calculation part is very, very simple. But if we just go on solving the concept, you can directly jump onto the answer. And before jumping onto the answer, read the question. I've also told you how to, because there the answers could be in such a way that they are misleading and confusing. So first read the question. Calculation में कुछ ज़्यादा time नहीं लगता है. It's very simple, but know what are the basic formula we are using, what are the basic concept we are using, and then you solve it. Okay? Thank you. We'll be definitely meeting on a different day.